Trino is a query federation solution that lets you run SQL queries on data kind of wherever you've got it, whether it's in buckets in S3 or in a database or in a spreadsheet, wherever. It'll have connectors to go off and get all that stuff and query it and give you the results. Not classically considered a real-time analytics technology, but there is a connector to Pinot that enables some really, really cool stuff. I've got the author of that connector, Elon Azoulay, on the show today to tell you all about it. Let's listen in. Hello and welcome to another episode of the Real-Time Analytics Podcast. I'm your host, Tim Berglund, and I'm joined today by Elon Azoulay. Elon is a software engineer at Starburst. Elon, welcome to the show.
Hi, thanks for having me.
You got it. Thanks for coming on the show. Now, you have been involved in writing the Trino Pinot connector. That's hard to say precisely. Yeah. I want to talk about that today. But first, in case anyone is not initiated into the mysteries of Trino, what's Trino?
So Trino is a massively parallel distributed SQL engine, and it's based on connector architecture where it'll connect to your data lake, to Postgres, to Pinot, to Kafka even, and you can do advanced analytics and queries over your disparate data sets, and it's like SQL on anything. You can even have a GitHub connector if you want.
Oh, it's nice. I can do SQL queries of files in a GitHub repo.
Yeah, and like your GitHub test runs and success rates and duration.
Oh, actually, like API stuff. Okay, very cool. I mean, okay. Now, so I knew SQL over anything. I got to tell you, I was not ready to expand to my definition of anything to include things I might get out of GitHub's API. I was thinking more like maybe I've got some stuff in S3 and I've got some stuff in a database, and I need to do federated queries over all those things. I mean, is that kind of the
that's the common typical use case. There's even a connector for Google Sheets, so you can import your Google Sheets data. Yes. And SQL on anything, preferably Pinot and S3. But
there you go. I'm with you. I'm with you on that. So yeah, I mean, I guess kind of the old school or the original, I don't want to say old school, but the original idea of a data warehouse from 30, 35 years back was go and get all the things and put them into a database with a specially designed, carefully engineered schema, and then do SQL queries over that thing to build reports. And it kind of like you're cutting out the middleman. You're just going to be distributed SQL wherever your data is. You'll go get it.
Yep.
There you go. Now, and this goes under the broad heading of query federation, which makes sense, right? You got all these other things that may themselves have some way of executing queries, or may just be piles of data like CSV files somewhere or Google Sheets somewhere, and you just do queries over all those things. Yep. Now, I wouldn't. This is called the Real-Time Analytics Podcast, and I wouldn't normally put that in the category of being real-timey because the value there is the anywhere, and so you might be going out to weird data sources and that might take some time, but
right,
absolutely critical component in whatever the modern data stack actually is. Trino often shows up there. What can you? I mean, I want to talk about the connector and what motivated you to write it, and use cases and things like that. I want to get to all that, but for those of us who don't know Trino well, can you give us an idea how it works? I mean, you said connector based, and that makes sense given the, you got to do all these things. But where's it run? How's it fit in? Just kind of give us that basic architectural rundown.
Sure. So it's based on a plugin architecture, and people contribute code. A lot of it's from Trino and from Starburst, where you write the code that says, like, this is how you select, this is how you filter, this is how you push down aggregations and joins and things like that. And then you give it a properties file to connect to your data sources, and one for each connector. And so you can connect to Pinot, you can connect to S3 data lake, Postgres instance, MySQL, and you could do joins. You could, for example, get your real-time data from Pinot and then add it to your, analytics table in S3, so you could do more complex and more batch style analytics also. Um, but also, one other benefit that we used it for was, let's say you have an error, like ingesting data in Pinot for some reason from Kafka, you can actually use the Kafka connector to debug, which messages and what the error was if the schema changed. That's happened tons of times. So that was a really useful, one of the really helpful uses of the connector.
Nice.
Another one is being able to join, let's say, to a Postgres database and doing more, slower but more analytically intense queries, like with, having filters or aggregation filters, so window functions, things like that, where you could take the real-time data, process it, and join it with other data that you have.
Yeah, and that joining of sort of this, that, and the other thing in disparate places is the idea. Again, the cutting out of the middleman. You're just going to do the join on the data where it sits. You're not going to bring it all into one place.
Right.
What is the process that things plug into? There's got to be some core kind of what it is to be Trino. What's the physical architecture of the thing look like?
So you have a coordinator that's similar to the broker endpoint in Pinot, where that's where you query against. That's the endpoint,
Yeah.
And then you have workers that actually do the work. That's similar to the Pinot servers, where it'll you put together a plan, and then it'll go out to the different connectors and pull the data in and do the aggregations and filters. It'll actually push as much as it can into the connector, and we did a lot of work to do that with Pinot, and there's even more ongoing work. So you can have like a native Pinot query and push it, or a native Postgres query, push it, and then just join the result sets instead of getting all the results and doing the filtering in the Trino engine. And that's a game changer in terms of latency.
It's got to be, yeah, because nobody wants to, because you mentioned in the definition of a plugin, you can push down things like aggregations, and I'm sure predicates, and anything you can push down, you want to be in that kind of terminal place,
right?
Because it's more likely to be tightly coupled with its storage, and it'll be faster, and then you get the things back from the everywheres, and you do the join or the reduce, or whatever that thing is that you're doing at the end.
Yep, exactly. Another good. Oh, sorry.
No, you go ahead.
I was going to say another feature is Pinot has a gRPC endpoint. That was one of the. I was honored to be able to contribute that, so that you can actually get the data directly from the servers. If, for example, you'll have a production Pinot with a broker with highly curated queries that power real-time customer data dashboards. But let's say you want to do some advanced analytics, and it's on all of the data, and you don't want to affect the brokers. This will directly go to the servers and pull the data in. So if you want to use it to export the data into like a more long-term batch data set that you want to do your batch analytics on, or just sometimes we actually use that for debugging. Also, like if you see latency on the broker, but you can get the queries quickly on Trino through the servers, then we know we can pinpoint where the issue is. But the main use case for that was just to get the data, if you need bulk data, it's actually much easier on Pinot to do it through the gRPC endpoint. If you do it through the broker, you'll crash the broker. So this way you can have your workloads coexist, multi-tenant environment where you have people querying the broker for production, and then for analytics, you hit the servers and may not care as much about the latency.
For offline analytics where you don't need real-time latency.
Although you get the Pinot's fast though, so.
Yeah, right. And we talked about this on the podcast before, but the business analyst use case currently, we're recording this in late October 2023. Ask me in 2026 if this is changing, but most of the people who are looking at a dashboard, they don't need it to be 1,000 times faster. When you're delivering analytics to users in a user interface as a feature that's powered by analytical queries, well, yes, that has to be Pinot speed, but
Yep.
a lot of the, I mean, like look at me as a DevRel leader, the stuff that I need to see. Yeah, daily's fine. You know, how many people RSVP'd to that meetup in the last 5 seconds? It's not really how it goes for me. Now, plenty of people need the real time stuff, but the typical business analyst doesn't. And so you're saying, because I mean, the whole, select star, give me the whole table from Pinot. That's kind of rude. You don't.
Yeah, you'll
That's not
kill
what
it.
OLAP databases
not,
do.
Not what it's for.
Yeah, they're all designed to you either aggregated to a scalar, or a group of scalars, so like a key value pair set of fairly low cardinality. When you want all the things, you go straight for the gRPC throat and just extract.
Right.
Pretty cool. All right. Nice. That's actually a TIL for me. I did not know that was a part of the functionality. So thank you for contributing that.
Yeah. Thanks for accepting my contribution.
Well, I didn't do it. I am not I'm not one who approves PRs on the Pinot project, but I'm glad.
I love the community though; it's so helpful, and that I learned.
Nice.
Like I originally learned about Pinot at my last job, a startup, and we chose it actually because the community was so engaging, and started working with us, allowed us to contribute, learn, and we've grown with Pinot. So yeah, we love it.
I love it. Hey, so, dear listener, Elon and I did not arrange that comment before we recorded at all. That was completely spontaneous. I'm glad. I am very glad that that's been your impression.
Oh yeah,
because that's what I see in the Pinot community from a user standpoint. So like developers using the database as a database to deliver features in their stuff that they're building. But there's the community of the people who are building Pinot, and I mean I know some of those people, and I know that they're delightful.
yep, they are.
But I don't see that level of interaction as much. Like in my day to day, I'm more like, okay, how are people trying to make Pinot work from the outside? But it's nice to know you can get a contribution in, and that's still a pleasant process. Nice, but not surprising again, given the quality of those folks there.
Yeah, and that was a game changer for us. We evaluated a few different real-time analytic databases, and that was one of the clear. Besides the performance, that was a clear differentiator. Even just for users that post in troubleshooting or general, you always get 5 people replying and helping you.
Nice, yeah. And I got to tell you, I mean, I don't. So I mean, this podcast as a whole is not just about Pinot, but of course, my work is trying to make Pinot famous among developers on planet Earth. And as a person whose job that is, I don't have to run away from performance conversations. Benchmarks are a dirty business, and I don't like to go there. That's like, it's just a tough place to fight and feel like everybody's telling the truth. Everybody's got their own spin on things. It's nice when other people say that though, like somebody else goes and runs some numbers. Like a year or so ago, had some folks at WebEx did a webinar about all their performance kind of bake off, and those are in context of a real system. It's not somebody tuning a benchmark to make it look good. They're always better numbers, and that happens, right? When people do that with Pinot, it works in terms of performance. But I would say, even if that wasn't the case, I think strength of the community when you're making an adoption decision like this in an open source context, and there are some nearby choices, I think strength of community is the better thing. I mean, that's the more important piece of the puzzle.
Yeah, and recently we actually so now I was using it before. It was called StarTree. It was just Pinot, but now we have StarTree, and you have the SaaS product, and Starburst also has the Galaxy SaaS product. And we recently added the Pinot connector, so we can connect from Galaxy to StarTree also. So users that use both platforms now can connect to each other.
I love it. Oh man, that's so great. So is there anything else interesting about the connector that you want to dig into? Like, the experience of, not the community experience of writing it, but on a technical level, were there any interesting problems to solve? Is there anything worth?
Yeah, there's a ton of, it's one of the most fun things to work on. One of the other great uses for the connector was onboarding data. So if you have like a small Postgres table or a dimension table or the result of a report, and you want to add it into Pinot so that now people could use it to power their dashboard and get the results in, milliseconds, and do, aggregations and filters on
Like
those
a
results.
smallish amount of reference data that you might want to join to or something like that.
Right, but also it works for huge data sets. That insert, it's almost landed in production, but in my last job, we were actually using it for a year and a half, where it was constantly, it would be like tens of terabytes per hour uh, ingested via insert. So you can use it for Lambda architecture. For example, you ingest your real-time data, but then you have another process that you sanitize the data and you upload it to the offline table. And Pinot's
Right.
designed for that. The real time and offline table types. It's perfectly designed for Lambda architecture. And by enabling users to just say insert, my new data, instead of having like a separate external job, like like a
Minion.
Spark job or something like that, you could
Oh,
just
okay,
have
or a Spark job.
yeah, you could just have it in a single SQL statement, and it really empowers data engineers to just, onboard tons of data to Pinot. So you have it
Okay.
real time ingestion, and sanitize it, upload it to offline data, and that's a pretty helpful feature.
And so technically, Trino is executing that SQL statement, but with the Pinot connector, it's inserting via the Pinot connector into it's like creating segments.
Oh yeah, and it does it. So it does it using the new Pinot APIs for the metadata upload. So it doesn't even affect the server. Earlier versions of Pinot, you had to upload the data to the controller. That would increase latency and memory usage. So it would
Right.
limit the scale. Now that's completely those limits are eliminated. So you upload your data to S3 or GCS or Azure. Then you tell the controller, "Hey, my data's over here." That's the
My
standard.
segment
Right.
is in S3.
And it uses the Pinot libraries to build the segments on the Trino workers in parallel. So it's not like just selecting from a single node and then uploading to Pinot. It's actually taking all the data and in parallel uploading the segments. And there was a recent improvement in Pinot where you have the atomic API, so you could do atomic replacement. So users won't even know, like, for example, if an insert failed, you would still have the real time and offline data that was there. But if it succeeds, it'll succeed atomically. So you won't see some crazy like spike and like a peak and a valley before the data is available. It'll just come up online
There you
atomically.
go. Okay, no, that makes a lot of sense. I am honestly getting a sense for how powerful this is. So if you've got if Trino's in your life and Pinot's in your life, you want this integration, because that might be a really easy way to onboard data. Because the thing is, it is it would be very surprising if you say, okay, we have to start. We're going to start using Pinot. We're going to roll Pinot out because there's some real time analytics requirements we have. We're moving to that world, and oh look, here's exactly the data we have. Here's this S3 bucket, and look at these Avro files. It's exactly the columns, and what would be the odds? Or here's my Kafka topic, and it's just lying there, ready to be ingested. It's not usually like that. You've got data, and it's all in various forms, serving other things that you've been doing with it in data pipelines and in applications. And you kind of usually have to squish stuff around a little bit before you ingest it, whether it's streaming ingest into a real-time table or batch ingest into a so-called offline table. You have to mush stuff around a little bit. That's just the nature of data, and that's 90% of the job is doing the cleaning and the enriching and the
Right.
as I say, the mushing. And there's all these ways to do that. There's the Spark API, there's the older school Hadoop API. There's libraries where you can create segments directly. There's of course, Kafka ingest is just from a topic. But if Trino's there in your data stack, that's probably going to be a lot easier, because you're now going to be able to express those transformations just in SQL the way that you normally would. And if you can get away with that, man, you'd much rather.
Yeah, exactly. As soon as we enabled this feature, the amount of data in Pinot exploded, and that was a great learning. And Pinot handled it perfectly. We scaled up. This is around the time that the uh, pool-based server allocation strategies started to be implemented. So you could scale up your tenants and separate them with pools, so you have zero downtime. And
Yeah.
the
Server
data
pools,
just
right?
mushroomed, and data engineers loved it. And luckily, I was on the infra team, so we, just scaled seamlessly.
Nice. Okay. All right. We'll put a link in the show notes to server pools if you want to go deep on Pinot. We don't need to talk. We don't need to dive into that right now, but that is an important concept that is relatively new.
And great, zero
Yeah.
downtime for Pinot, basically.
Nice. Okay. All right. Huh. Well, you know, I started this conversation thinking this sounded like an important thing, but you're actually selling me on it. I mean, it's it's game changing. Again, it's one of those things where if you didn't have Trino as a part of your stack, maybe you wouldn't spin it up just to make your Pinot life easier. Maybe you'd use the other facilities, but there is an awful lot of Trino in the world and an increasing amount of Pinot, and so more of a chocolate and peanut butter kind of thing than we thought.
Yeah.
And for my non-US listeners, I have recently learned that I think it's only Americans who think that chocolate plus peanut butter is really delicious. And so what that means is a really good combination. And if you haven't had chocolate and peanut butter, just side note, you should try it. It's 4 days before Halloween as we record this. So
Yeah, good
um,
timing.
yeah, I'll be hitting some chocolate peanut butter cups, Reese's peanut butter cups in a few nights. Uh,
Yeah, Pinot and
anyway,
Trino go together. StarTree and Starburst. It's a match
really
made in
is.
heaven. Data
Oh, I
heaven.
love it. What's last question? Your favorite thing you've seen someone doing with this? And you mentioned a few, but what's the coolest that comes to mind?
We had a data team that actually wrote. Customers wanted their data in real time, but then they also wanted some aggregate data joined with Postgres. So they created this dashboard that called out to Pinot via Trino, and then joined with Postgres. And the customers were getting the data directly from like the query just seamlessly on this beautiful dashboard, and they loved it. It was for all the customers in my previous job, actually, that used it. They would just click up their tablet and see all of a sudden they have all these metrics about their business that they never saw before. And another really useful one is using Pinot for anomaly detection. And we used to have you would find out about an outage like 2 or 3 hours later. It would be global scale by then. With Pinot, you could actually find out within like seconds, and that pretty much eliminated all the outages uh, that my last job had.
That is powerful, and this sounds self-aggrandizing because I'm about to talk about a light board that I just released. Yeah, Elon. That reminds me of a video I made.
Nice.
Who's the guest here anyway? No, but the idea of detecting anomalies automatically and faster, because a lot of the cost, I mean, anomalies, root cause detection, once you know about an anomaly, is expensive because you need a lot of human beings looking at the problem, and all the data isn't always in one place. You got to, go build special queries, write special jobs, pull stuff in. That could be really nasty. But just learning about the anomaly in the first place, if you don't have automated detection, you have to find some effect that might be 4 or 5 links down the chain from the actual precipitating event. I always want to put an asterisk when I say the word root cause, because what we mean is the largest contributing factor. There's never a root cause. I deny the existence of root causes, but the big thing that is the thing that happened that relied on other factors and kicked it off. But that's links down the chain when the thing that you finally see, because you're not monitoring this thing. And so when you have automation wrapped around that detects those things in seconds, not only do you incur lower costs as a result of the anomaly, but you can maybe detect a thing that's closer to the actual root. And there's so much value to be had there. I'll link. We did a video on that recently.
That's great. Yeah, Pinot basically eliminates blast radiuses.
Yes, makes them smaller, which is what we'd like. Yeah. Well, hey, thanks for this contribution, of the code, and for helping me see really all the, beyond just two pipes connecting, all the kinds of things it unlocks.
Yeah, and I look forward to contributing more and look forward to engaging with the great community.
My guest today has been Elon Azoulay. Elon, thanks for being a part of the Real-Time Analytics Podcast.
Thank you.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.